this video, we're going to look at calculations involving atoms and mass. These calculations are interesting. What if I wanted to know the mass of one silicone atom? What's kind of weird is that there's no way we could really prove it or test it in the lab. We can calculate the mass on paper, but with everything I know about atoms, I'm expecting this mass to be crazy, crazy small. There's two different ways that you could set this up, a long way and a short way. Here's kind of the long version. So you start with what you have. I have one atom of silicone. I want to do a conversion where I cancel atoms. And in the past we've gone atoms to moles. That was an easy switch. 1 mole was 6.02 times 10 to the 23rd particles, in this case atoms, which then I can cancel atoms, and I'm at moles. However, when they say determine the mass, we're really looking for an answer in grams. I could do another proportion, so let's tack on one more. Right now we'd be at moles, which I don't want my final answer in moles, I want grams. And I know that 1 mole would have the mass on the periodic table, the molar mass. So I look up silicone, 28.09. Moles and moles will cancel, and then I just plug this in my calculator. I'm going to multiply across and divide by anything on the bottom. So I really have 1 divided by 6.02 times 10 to the 23rd times 28.09. And for significant figures, maybe I'll leave like about 3. I don't know if I want to just go to 1 sig fig. So how about 4.67 times 10 to the negative 23rd? And that would be grams or grams per atom. Okay, yeah, now you see what I mean. That number is crazy small. I'd have to take the decimal spot backwards 23 spots. So it'd be like 22 zeros and then 467. There's no way I could measure that in a lab. I think the gist of it is that we should understand how small an atom really is. I mean, the mass of one individual atom is really immeasurable. It's so small. Okay, so I could do the same thing with tin. I have 1 atom of tin. 1 atom tin, SN. I want to get it out of atoms. And let's go to moles. Because I know 1 mole is 6.02 times 10 to the 23rd atoms. I like that. Atoms will cancel. Right now I'd be at moles, but from moles I can switch it to grams. I'd cancel moles, put it in grams. The molar mass of tin on my periodic table is 118.71, and that molar mass is for 1 mole. Moles and moles would cancel. I plug it in my calculator. 1 divided by 6.02 times 10 to the 23rd times 118.71. And again, my math is small. Maybe like 1.97 times 10 to the negative 22nd. And you could say grams per atom. Crazy, crazy, crazy small. Now, if you're not getting that, maybe try putting the 6.02 times 10 to the 23rd in parentheses. Sometimes that causes problems with your calculator and order of operations. If this were multiple choice, often there's only one reasonable answer. The mass of 1 atom should be astronomically small, 10 to the negative something grams per atom. So here's this other option. Here's a little bit of a shortcut. What if I had one molecule of carbon disulfide? Carbon and 2 sulfurs, covalent. The shortcut would be cancel molecules. Just switch it to grams right away. I know anytime I see atoms or molecules, it's the 6.02 times 10 to the 23rd. And whenever I see grams, I go to my periodic table. Now if it's a compound, I just have to add. So I'm going to take carbon plus 2 times sulfur. And my molar mass, 76.14 grams. So my units all cancel. I mean, molecules and grams is the unit that I want. You can kind of do this in one shot. It's really the same calculation that we did above. It's just understood that the molar mass, that 76 grams, that is not the mass of one molecule. That is the mass of a mole of molecules, which is 6.02 times 10 to the 23rd. So we can still divide these two, and we should still get a very small number. So I'd be looking at like 1.26 times 10 to the negative 22nd grams per molecule. Super tiny. So if you like the shortcut, you can do it all in one. I'm totally fine with that. You're still showing me the same information. 1 molecule of sodium nitrate. Now this one is ionic because sodium's a metal. So I look up his charge. And then I need to have my polyatomics handy. Nitrate is -1. If you need to show work, like on the homework or on a test or a quiz, this is what I need to see. We're going to cancel molecules. Switch it to grams. Molecules, 6.02 times 10 to the 23rd. And the mass comes off my periodic table. I just need to add. This will be sodium plus 1 nitrogen plus 3 times oxygen. Only 3 for the oxygen. The only time I would distribute the 3 is if maybe nitrate were in parentheses and there was a 3 outside the group. I only have 1 group of nitrate. There's 1 nitrogen and 3 oxygen. For a total of 84.99 grams. Molecules cancel. I can divide for about 1.41 times 10 to the negative 22nd grams per molecule. There. Show that much work. Show me the formula that you used. Show me your proportion. In your proportion, you tell me that you have everything set up correctly and you have the mass that you used. So if your final answer is wrong, I can kind of walk through your work and your setup and figure out where we went wrong. Now if you can do that, you can do this last set. Here we don't just have one atom, we have a lot of atoms, but it's the same setup, exact same setup. Start with what you have, 9.55 times 10 to the 23rd atoms of lead Pb. And again, I don't care if you want to do the 2-step or the 1-step. In the 2-step, I would cancel atoms and make a pit stop at moles. Because I know 1 mole has 6.02 times 10 to the 23rd atoms. Atoms will cancel, and I'd be at moles. If it asked me how many moles, I'd be done. But if I need to go to grams, I just tack on 1 more. Cancel moles, let's put it in grams. The grams will come off a periodic table. This is lead. 207.2 is my molar mass. And that mass is just for 1 mole of lead. There. Well, my units should all cancel. There we go. Moles and moles. You are out. I'm going to multiply across the top, divide on the bottom, and I could even take a little extra shortcut here. These are both 10 to the 23rd, so we could cancel those just to make it a little easier to put in our calculator. So I'm going to multiply 9.55 divided by, well, I should say divided by 6.02. Then multiply by 207.2. Now obviously it doesn't matter what order you do that in. Your final answer with 3 significant figures is 329. 329 grams. And again, we can see if that sounds reasonable. 9.55 times 10 to the 23rd is about, what, like 1.5 moles? Every mole is 6.02 times 10 to the 23rd particles. So I have about 1.5 moles. Each mole is about 200 grams. Yeah, I'm looking for somewhere around 300 grams. That seems reasonable. So there's your long way, the 2-step. But again, with these two, you can use the shortcut. You can combine these in one step. 3.072 times 10 to the 24th atoms of silicone. I do not want this in atoms. I want it in mass or grams. The mass of silicone is 28.09 grams, and that is the molar mass. It's not the mass of one atom. It's the mass of a mole, 6.02 times 10 to the 23rd atoms. Atoms will cancel, and I can plug this in my calculator. Now again, this time I have to be a little bit careful. They're not both 10 to the 23rd. So again, you could just plug this in your calculator. If you're using the caret key, like times 10 caret 23, you might need to put these in parentheses so your calculator does order of operations correctly. Or, if you understand scientific notation, you could just say like 30.72 divided by 6.02 and then multiply by the 28.09. And if I leave this as 4 sig figs, 143.3 grams. Not bad. Yeah, these aren't bad. I mean, here this is nice because everyone is solved the same way. So if you want to, you can pause the video, try the last two, bring it back, see if you're getting the answers correct. But if you can set up one, you can set up all just by getting the units correct. Alright, so let's try these last two. I have compounds and I'm looking for grams, so I will need the formula. 1.18 times 10 to the 23rd of molecules of silver 1, silver plus 1, chloride, which is minus 1. Well, that's not so bad. We'll set up our proportion. We'll cancel molecules and switch it to grams. Anytime you see atoms or molecules, the particle, it could be atoms, molecules, ions. The individual particle, 6.02 times 10 to the 23rd particles per mole, and the mass of a mole would come on your periodic table. And so yeah, I would need to add silver plus chlorine, 143.32. Which is kind of funny. Like, coincidentally, that was kind of the answer to number 2. All right, let's see what we can cancel here. Molecules and molecules, yes. And they are both 10 to the 23rd. Just makes it a little easier to put in your calculator. 1.18 times 143.32 divided by 6.02 for about 28.1 grams. Not bad, right? And so one more, the very last one. I start them all the same way. You got to put not only the numerical value times 10 to the 23rd, but the unit. Molecules of tin, SN. Tin is plus 4 hydroxide, OH, minus 1. So to make that neutral, I'm going to need 4 hydroxides. Then if I know my original unit was molecules, I'm going to cancel molecules. We want it in grams. There are 6.02 times 10 to the 23rd molecules in a mole, and a mole would have the mass on the periodic table. Now this time I will need to distribute. I need 1 tin plus 4 oxygen and 4 hydrogen. So this mass is about 186.75 grams. Molecules and molecules will cancel, and yes, I can cancel the 10 to the 23rd. All right, let's see what we got here. 2 times 186.75 divided by 6.02. And with just 2 sig figs, 62 grams. Now I love this one because it makes sense. 2 times 10 to the 23rd is about 1/3 of a mole. A mole is 6 times 10 to the 23rd. So I should have about 1/3 of the mass. The original mass was like 180 something. So yeah, I have about 1/3 of the mass, 62 grams.